We're continuing with rational expressions and equations, but this time we're going to use applications like work problems. Okay, many seemingly different applications fall into a class of problems known as work rate problems. What these applications have in common is two or more workers acting in concert to complete a task. That just means one or more people or things working together to complete a single task. Workers can be people, they can be machines, they can be pipes, anything like that. And normally each worker is capable of doing the task alone, but when you put them together, then it takes them less time to complete that particular task. The goal in a work rate problem is usually to determine how fast the task at hand can be completed, either by the workers together or by one of the workers individually. There are two keys to solving a work rate problem. One of those is rate of work is the reciprocal of the time needed to complete the task. That's a really important thing to know right there. Rate of work is the reciprocal of the time needed to complete the task. For example, if Jane can overhaul an engine in 2 hours, her rate of work is half of the job per hour. Does that make sense? If she can complete the whole thing in 2 hours, then half of the job can be completed in 1 hour, right? If a faucet can fill a sink in 5 minutes, then it can fill 1/5 of the sink or 1/5 of the job in 1 minute. Okay, so that's how that works. And then number 2 is rates of work are additive. This means that in the ideal situation, two workers working together on the same task will have a combined rate of work that is the sum of their individual rates. So if Jane's rate in overhauling an engine is 1/2 and Ted's rate is 1/3, then their combined rate is 1/2 plus 1/3, or 5/6 of the job in 1 hour. Okay? So let's see if we can work a problem. One hose can fill a swimming pool in 15 hours. The owner buys a second hose that can fill the pool in 2/3 of the time of the first one. If both hoses are used together, how long does it take to fill the pool? Okay, so we have hose number 1 and we have hose number 2. Alright, hose number 1 can completely fill the pool in 15 hours. This is for the total job. So hose number 2 takes 2/3 of the time. 2/3 of 15 would be, well, 3 will go into 15 5 times, and 5 times 2 is 10. So it takes the second hose only 10 hours. Now that's if they work separately to fill the pool. So the question is, if they're both used together, how long does it take to fill the pool? Well, remember their rate. This one would be 1/15 of the job per hour, and this one would be 1/10 of the job per hour. Well, if you add the two rates together, it equals the total rate, which is 1/x, because that's what we don't know. How long does it actually take them together? So that's the hard part, actually setting up the equation. Now we need to solve the equation. So what we need to do is multiply by the least common denominator, which will be 30x. When you multiply 30 times the first fraction, we end up with 2x. 30 times the second fraction would be 3x. And then 30x times 1/x would just give us 30. Combine your like terms and divide by 5. So x is equal to 6. That means it would take them 6 hours working together. The pool owner in example 6 is a bit clumsy, and one day proceeds to fill the empty pool with the two hoses, but accidentally turns on the pump that drains the pool also. Oh, that's a big waste of water, isn't it? Fortunately, the pump rate is slower than the combined rate of the two hoses, and the pool fills anyway, but it takes 14 hours to do so. Wow. So in that previous problem, it took 6 hours to fill it. This time it took 14 hours. That means he wasted 8 hours of water. Okay, at what rate can the pump empty the pool? So we still know that the combined rate of the two hoses is 6 hours for one job. So we take the reciprocal, 1/6, but this time the water is being taken away at a certain rate that we don't know. So that would be 1/x, because x is what is being taken away from the pool. Equals, well, what was the rate? It was 14 hours, right? So we take that reciprocal. So we have our equation. Now we just need to solve it. So your least common denominator this time will be 42x. Okay, multiply by the 1/6 and we end up with 7x. Multiply by the 1/x and we'll be left with 42. And multiply by the 1/14 and we'll be left with 3x. Let's go ahead and subtract 7x from both sides and divide by -4. So x will be equal to a positive 21/2, or 10 1/2 hours. So the pump can empty the pool in 10 1/2 hours.